Today's video is part of a series of precompiles proposals for the Ethereum Virtual Machine, or EVM. A precompile is a native smart contract that lives at a known address. The precompiles that the EVM implements do not have an associated bytecode, but are natively implemented in the Ethereum client in the language of that client. Today you will see a precompile for gas refills. With this, a user can make a transaction that reaches the gas refill precompile, storing an amount of gas to be used in a separate transaction in the future, like user 2 does. Then another user, like user 1, can request that gas from the gas refill precompile and use it to pay for a transaction done on behalf of user 2. With this, users and contracts can prepay for future transactions, and it can be possible to earn native tokens from nothing, just for providing a cron service for other users. This is a dApp that exposes 3 contract functions. The first function performs something, just stores 10 new slots in the contract storage and charges the sender the full price, just like a normal transaction. The gas store function allows a user to send gas into the account of the smart contract through the gas refill precompile. This gas will be used for the perform something with gas recover function and will pay for part of it or all of it. We are running this dApp on a local modified Geth node with an implemented gas refill precompile. So first, let's store some gas. 200,000 gas units. And we are going to be using a gas price of 21 GUI for all the transactions that we are doing. And we can see the gas used is 200,000 plus the actual cost of performing the gas store transaction, which is 24,906. Let's store some more gas. 400,000. And now gas used is 400,000 plus the cost of the actual transaction. Now let's see how much of our balance is used to execute this base perform something operation. If we click on this balance button, we get the current account balance here and then the difference between the current balance and the previous one in this diff. So let's click again and leave it on 0. Now let's make this transaction. And we are using again a gas price of 21 GUI. So we see it uses 255,060 gas units. And this is the amount of balance that was consumed by executing this transaction. And this is around 10 to the power of 15. Let's leave this difference at 0 and let's execute perform something with gas recover, and we will request 250,000 gas units. With a gas price of 21 GUI. This transaction consumes 261,197 gas units. Now let's see how much balance we consumed. And it is around 10 to the power of 14, so an order of magnitude lower than what we did before. So let's see what happens now if we request almost the entire amount of gas, but instead of the 7, we will put a 0. Let's leave the balance at 0 and confirm the transaction. This is the amount of balance that we have consumed, and this amount should be equal to this 7 multiplied by this gas price in Gwei. And it is the same amount. And of course, we can try one more time, store some more gas. And this time, we will want to request the entire amount of gas. And now, if we click on the balance button, we get a 0, because this time we did not pay anything for making this transaction. You just saw an EVM interpreter precompile implemented in a fork of Go Ethereum or Geth, an EVM native contract that can store and refill gas to specific accounts and contracts as message sender, transactions, or sets of the above by Bloom filtering. It may act as a promise to pay for future transactions, and in next versions we will increase flexibility and usability.